We'll continue with section 6.5, properties of logarithms, and we'll work on some more problems on page 457. So first we'll do number 28. It says here, find the exact value of this expression. Do not use a calculator. So we have e to the power of log base of e squared of 9. Now we do have a formula, a property of logarithms that involves here a base. When I have the base b to the power of log base b of a, that will be equal to a. But in order to apply this property, I have to have the same base b here and base b in the logarithm. So as you can see here, the base of this logarithm is not e, is e squared. So we will take this logarithm on the side, log base e squared of 9. We're going to write the 9 as 3 squared. And now, according to the property that involves exponents, these two exponents, 2 and 2, both of them go in the front of the logarithm, but they go as a fraction, so it's 2 over 2 log base e of 3, or natural log of 3. So that would be equal to log base e of 3, or natural log of 3. So again, the formula that I applied here is this. If I have a log of base b to the power of n, let's say, and here I have a to the power of n, then both of these two exponents, m and n, can be moved in front of the logarithm. But again, when they move in front of the logarithm, they go as a fraction. So that would be m over n log base b of a. And this can be proven with the change of base formula for logarithms. That's what I applied. So now going back to our problem here, e to the power of log base e squared of 9 is actually the same as e to the power of natural log of 3, or log base e of 3. So according to this, since I have the same base here and here, the answer would be 3. So that was number 28. Now we move on to number 34. For number 34, it says, knowing that natural log of 2 equals a and natural log of 3 equals b, find natural log of 27. Says use properties of logarithms to write each logarithm in terms of a and b. So our answer for this natural log of 27 should just have only a and b, and eventually some numbers, some constants. So I look here and I see that I have 27, and I know that I can write 27 as 3 cubed. And why I'm thinking to do that, because I know that natural log of 3 is b. So I'm going to replace 27 with 3 to the third power. And now we can take this 3, the exponent, and move it in front of the logarithm. So now I have 3 times natural log of 3. But at the same time, we know that the natural log of 3 is equal to b. So actually our answer is going to be 3b. So we have an answer in terms of b. That was number 34. Now we move to 36, where we have to do exactly the same thing to write the answer in terms of a and b. And we have to apply the same conditions here. Natural log of a is b, natural log of, natural log of 2 is a, and natural log of 3 is b. So for number 36, we know the natural log of, we have the natural log of 4th root of 2 over 3. So we know that we can use only these two conditions here. So what we're going to do, we can replace this 4th root with an exponent. So that would be natural log of 2/3 to the power of 1/4. Now we can move the exponent in the front. And why? Because in the end we have to use that, we just want to use natural log of 2 and natural log of 3, but right now we have natural log of 2 over 3. So we move the 1/4 in the front, then we have natural log of 2/3, and according to the difference of logarithms, this is going to be 1/4 times, parenthesis, natural log of 2 minus natural log of 3. But we know the natural log of 2 is a, so this is going to be replaced with a. We also know the natural log of 3 is b, so this is going to be replaced with b. So our final answer is going to be 1/4 times the quantity of a minus b. Okay, now we'll move on to the next group of problems. And for all of this, it says write each expression as a sum and or difference of logarithms and express powers as factors. So we'll do number 39. And for number 39, we have log base 2 of z to the 3rd power. So here it says express powers as factors. So this power, this 3, the power, can be moved here in the front and becomes a factor. So it's 3 times log base 2 of z. And that's it. There's nothing else we can do here. It's just one single log. I mean, actually there are 3 of them because it's multiplied by 3, but it's log base 2 of z multiplied by 3. Okay, we'll move to number 43. Same type of problem. We have to write natural log of x over e to the x as a sum or a difference of logarithms, and we have to express the powers as factors. So we have here a ratio, which means that this would be equal to the difference of the 2 logarithms of the numerator and denominator. So it's natural log of x minus natural log of e to the x. And now we can do just one more thing. We can move this x in the front here, since it says clearly in the directions that we have to convert the powers as factors. So this power x goes here in the front. So now I have natural log of x minus x times natural log of e. At the same time, we can also replace natural log of e, because we know that natural log of e is 1. So the answer would be just natural log of x minus x. Or we can leave it the way it was before. And now we move to number 46. Number 46. We have log base 2 of a over b squared, and they tell us here that a is positive and b is positive. So for this to exist, a should be positive and b should be positive. Okay. Actually, at this moment, b doesn't have to be necessarily positive, but if we move, you will see when we'll get rid of this exponent, we should have just b positive. So what do we do? So first of all, we have a ratio. So this would be the difference of the 2 logarithms, log base 2 of a minus log base 2 of b squared. And here for the second part, we can move the exponent in the front, becomes a factor. So now I have log base 2 of a minus 2 times log base 2 of b. So as you can see, if a is positive and b is positive, both of these logarithms exist. Okay, now we move on to number 49. Same type of question. So we have log base 2 of x cubed over x minus 3. And the condition is that x is greater than 3. So again, we have to write this as a sum or difference of logarithms, and powers should be expressed as factors. So we have a ratio. We convert this logarithm into a difference of two logarithms. Log base 2 of x cubed minus log base 2 of x minus 3. And we can take this exponent 3, moving in the front. So we have 3 times log base 2 of x minus log base 2 x minus 3. And since we have an original domain here given to us, x is greater than 3, both of these logarithms would exist for that domain. X is greater than 3, so this quantity is positive and greater than 3, and this is positive as well.